Okay, we are going to find the area and perimeter of regular polygons, and I think I'm going to do a hexagon, octagon, pentagon, and then like just a random 15-gon. So I'm going to give you 4 different examples on this video. So I'll start out with a hexagon. As a reminder, we already discovered that for a regular polygon, each interior angle is n minus 2 times 180 over n, right? N minus 2 times 180 gives you the total. Dividing by n would give you each one. And again, if it's regular, then they're all the same. Okay, so we already know that for a hexagon, this angle is 120. And we're going to be interested in finding the area of this hexagon. For this one, let's go ahead and pretend that we know the radius of it. Okay, the radius of it is this distance here. The radius is the distance from the center to one of the vertices. Okay, and so let's say we know that happens to be, let's just say 10. Okay, so with that information, I'm going to find a couple different things. I'm going to find the apothem, which is the perpendicular distance from center to side length, or the shortest distance to the center from the side. And I'm also going to find this. Okay, and in all these videos, I'm going to eventually draw that same little bitty triangle. I'm going to call that h, because it's kind of the height of the triangle. I'm going to call that one x. Okay, and the theory behind this is we have to use trig. All of this really is just trig. If I know that this angle is 120, then I also know that that angle is 60 degrees, right? The radius is going to bisect all of these angles, right? You can think about all of these guys and all of these triangles. Okay, I'm going to focus, you see how there are 6 big triangles? I'm going to focus just kind of on this pink and green triangle, which is what I would call the little triangle. And there actually are 12 of those in the hexagon. Okay, so let's find x and h. If we remember SOHCAHTOA, so I'll only write this down this first time, SOHCAHTOA. Okay, I'm going to use cosine to find x. Cosine is adjacent over hypotenuse. So cosine of 60 is x over 10. X is right where I want it to be, so I'm just going to multiply both sides by 10. And I'm going to get x. I'm going to punch that into my calculator. Okay, I'm going to make sure my calculator is in degree mode, which it is, and I'm going to get 10 times cosine of 60, and I get 5. And then I was like, wait a second, that number was just too nice. And then I got to remind myself, for a hexagon, I actually have special right triangles. And I'm going to write that down in a second. Let's pretend we don't know that, and then I'm going to do sine of 60 is h over 10, which then 10 sine of 60 is equal to h. And then this one we are going to go ahead, and if we do this, we're going to get a decimal answer. We're going to get 8.66. Okay. All right, I'm going to remind you of, for a hexagon, we actually do always get a 30, 60, 90 triangle. And we know that if this distance, the hypotenuse, is 10, the small leg is 5, and the long leg is the square root of 3 times bigger, right? We know that that relationship is always true for a 30, 60, 90. 1, 2, radical 3. Okay, so if this is 10, this is 5, and this is 5 radical 3. So this ends up being 5 radical 3, and we kind of already knew that. Okay, so if it wasn't a hexagon, well then we'd have to do stuff like this. So that's why I went ahead and just did it anyways. But if it's a hexagon, boom, 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 we get all these things exact. And here's what we're going to say. The perimeter of the hexagon, well, think about it. If this is x, then can't I just double x to get the side length? So don't I now know that the side length is 10? Because if this is 5, the whole thing is 10. And then don't I know that the perimeter of this thing has to be 60, and we'll say inches? Okay, what about the area? Well, let's find the area of the little triangle. The area of the little triangle is 1/2 base, which is x, times height. So in this particular case, it's 1/2 times 5 times radical 5 radical 3, excuse me. So that's 25 over 2 radical 3. Now remember, this area right here is the area of the little triangle. That's the area of the little triangle. Hopefully you can still see that. Okay. The area of the hexagon, well, how many little triangles are there? Again, how many of these little bitty guys are there in the hexagon? Well, there are, of course, 12 of them. So in the area of the hexagon is just going to be 12 times what I found there. Right? 12 over 2 is 6. 6 times 25 is 150. And so I get an exact answer of 150 radical 3 square inches. And that's how I'm going to do all of these. Every single one of these is going to be the same. Now, sometimes I have the side length, sometimes I have the apothem, and sometimes I have the radius, sometimes I have the perimeter. But I'm still going to eventually do roughly this same thing. For hexagons, what we actually just decided is that the radius and the side length for hexagon are the same. Okay, radius equals side length for a hexagon, which is a kind of a cool property. And so for hexagons, you always get this 30, 60, 90 triangle, which has that relationship. An octagon and a pentagon, we won't always have those things, so we always can't find it exact. Okay, so here is me doing an octagon. I'm going to do it roughly the same way. So an octagon has an interior angle of 135. Okay, this time, let's say for the octagon, I didn't know the radius. Let's say for an octagon, I knew that the side length was 24. So I have an octagon, a regular octagon with a side length of 24. Okay, I'm still going to draw my little triangle. Okay, I know that this is 135 degrees, right? So then I take 135 divided by 2, and so then I know that this angle is 67.5 degrees. Okay, if I know the side length is 24, then I know that guy is 12. And let's say I'm interested in finding then the height, which is the apothem, and then the radius of this octagon, and then we'll find the area and perimeter, of course. Okay, I'm going to use trig in this case. This is kind of some funky triangle. It's not a 30, 60, 90 anymore, but I'm still going to do trig. I'm going to do basically the same thing. I'm going to say that cosine of 67.5 is the adjacent over the hypotenuse. That's r. Cosine of 67.5 equals to 12. See how the variable was in the denominator here, so I need to move it with multiplication, and then I'm going to divide by this. So r equals 12 divided by cosine of 67.5, and we can type that in quick. 12 divided by cosine of 67.5, and we get 31, we'll say 31.4. Okay, and then I'm going to use we use tangent. So tangent of 67.5 is going to equal h over 12. H is where I want to be, so I just need to multiply by 12. 12. Tangent of 67.5 equals h. H equals 12. Tangent of 67.5 is going to equal 28.97. So we're going to, if we round at the nearest tenth, it's going to be 29. Okay, it's not exact, but we rounded it. Okay, so now I know these distances. Okay, so what we can do here is that we can find the area of this little triangle, right? We know that the pink area is going to be 1/2 times the base, which is 12, times the height, which is 29, okay? So that's just 1/2 times 12 times 29 equals 174 square inches or square feet. And then how many of the little triangles do you have for the octagon? Well, remember, the octagon has 8 big triangles and then 16 little triangles, because the little triangle is half of one of those. Okay, so all we have to do is take 174 and times it by 16. Okay, so the area, the big area of the actual octagon is 2784. And let's say these are in feet squared. So that would be square feet. That would be a radius in feet. That would be in feet. 24 feet would have been the side length. So I know the side length, I know the radius, I know the apothem, I know the total area, and the perimeter was actually really easy because you were given the side length. So the perimeter is just straight up 8 times 24. Right, 8 times 24 is 192, and that would be in feet. Okay, that makes sense. Okay, I'm going to end the video now to kind of keep it at roughly 10 minutes. I'm going to do another video. So this was part 1. I did a hexagon and I did an octagon. I found the area and perimeter and the radius and the apothem. And this one I start out with the radius, and this one I start out actually with the side length. Okay.